Going on now to topic 4 of chapter 5. Here we're going to get into factoring big time. And we're going to look at the strategy, keeping in mind that what we have over here if we put the letter A there, ax squared plus bx plus c is the standard form for the quadratic expression. And if we add an equal sign and a 0 to it, that's the standard form of the quadratic equation. And we will solve it by factoring this side and then using finding the zeros, the principle of the zero products that we just went over. Okay. So in the slides that follow, they take this trinomial and give you all the background on how to factor it. But I'll do it here as a lesson and go over the points as we go along. So step 1, is it in standard form? Yes. Now A here is 1, so we don't write that. B is 7, and C is 12. A, B, C. Standard form of the quadratic expression. Then we look at it carefully and say, can we factor out any common factor? And here, no. So the next step is to put a set of parentheses right underneath it, because you're assuming that this trinomial came about from multiplying two binomials. That is, we are going to undo the FOIL. Okay, so to get this first term, the f, we multiplied this by this to get that. So that's easy. We're just going to put an x there and an x there. Now then we did the outers, then we did the inners, but we're going to look at the last, the L, right now. Now here we want factors of 12 that are going to go there and there, but that they add up to 7. So what do we have? Well, let's list the factors of 12. 1 times 12, 2 times 6, 3 times 4, and then they reverse, but these are enough because as I write this one, I know it will add up to 7. So I've discovered it. Now, normally we do this mentally. We're thinking, what are factors of 12 that add up to 7? We go through these and then we say, 3 times 4. So we put that right there. And since they're all plus signs, this one's easy. You're just going to put pluses in there. And then you FOIL it and see if in fact it checks. So first, x squared. Outers, 4x. Inners, 3x. That adds up to 7x. 4 times 3 is 12. Okay, that one's good. Now, they go through this in a series of slides, and we'll just look at them quickly here. Okay, now, here they're giving you a little thumbs up on What is the middle sign here? Notice it's a negative. Now, in order to get a negative there, and yet have your third sign be a positive, both of these signs, and I somehow went the wrong way, there we go. Both of those signs had to be negative. We had to have the same signs there in order to get a positive 10. And if the middle sign were positive, again, we would need two positive signs to get a positive. So notice that these are just about the same, except the signs. Here are both negative, here they're both positive. So that's something else that as we move through these, we will look at. Now we're going on to this next one. And again, we look at it. And is it in standard form? Yes. Remember, A is 1. We don't write it. B is negative 8 now. And this is a positive 15. So our next step then, if we can't take any common factor out of anything, is to put two sets of parentheses. Now we're going to determine our first term. Again, that's easy when A is 1. We're just going to put the letters there. Now again, we're looking for factors of 15 that add up to 8. Notice it's a negative. We'll get to that in a moment. So 1 times 15. There's not a lot of choices. 3 times 5. Well, there's our answer here. 3 times 5. And now they both have to be the same sign so that when we multiply we get a positive, and they're both going to be negative. And if we FOIL this, it checks. Remember, the foiling is an important part of the checking. Okay, now we'll take a look at this one here. And I didn't need all of that writing here, but let's just do it. I'm going to write it over here for you. X squared minus 5x minus 24. Standard form, A is 1, no common factors. Two sets of parentheses. Our A term is 1, so this just becomes x and an x. Now here's an interesting case. Our third sign is negative. That means one of these has to be positive and one of these has to be negative in order to give me a negative third term. But my middle sign is also negative. That means I'm going to have the difference of two numbers, two factors that will be a 5. So let's write them out. 1 times 24, nope. 2 times 12, nope. Here the difference is 23. Here the difference is 10. And then we're going to go 3 times 8. Ah, I think I've discovered it. 3 times 8, the difference is 5. But which is going to be positive, which is going to be negative? Now our middle term is negative, so the larger of these factors will be the negative. And again, you're doing a little bit of trial and error here, because by foiling, you'll then see, I see I've already have an error here. I put a 5 there. It's supposed to be a 3. There we go. That's better. By foiling it, that's your second check. And if we FOIL it, yes, this checks, and there's the answer. And they give a lot more work here. So notice that in some cases you might have a negative as a middle term or a positive as a middle term. So it's just a matter of where you place the signs. And again, if you've got the right factors, you just place the signs wrong. By foiling, oh, I get them in the wrong place. And I've done that. And hopefully I don't do it too often anymore, but you may need to give it that extra check. Okay. Now, another item as we look at this is they want us to factor this. Well, our first challenge is it in standard form? And here we're going to say no. So what do? You put it in standard form. So t squared minus or plus 4t minus 32. Now the next thing you do is see if there's any common factor. No, and a is 1. That's still sort of the easy kind. 2 sets of parentheses. We're going to put our t there and our t there. Now notice you're almost halfway there just by doing this. Standard form, no common factors, 2 sets of parentheses. Now, what are the factors of 32? Well, 1 times 32, we can disregard that. 2 times 16. 4 times 8. That looks promising. Look at 4 times 8 is 32, but the difference of these two is 4. That's what we're going to use. Now notice I didn't put the signs in, but I know that since this is negative, the third term is negative, I'm going to have one of these as negative and one positive. And, you know, you might put them in ahead, but this way gives you more leeway. And your middle term is positive, so the larger factor is the one that's going to be positive. And again, you check it by FOIL, and that does check. Okay, now again, our a term in front of the a squared right there is 1. It's in standard form, but now we have an additional variable, but they just want us to work it. No common factor to factor out. 2 sets of parentheses. We're going to put an a there. And notice we have a b squared there, so we're going to put a b there and a b there. Now let this sink in. I have it in standard form, no common factor, 2 sets of parentheses. I've put my variables. So now I just have to concern myself with factors of 30 that have a difference of 1. There's a 1 there. And I'm not going to list them. I want you to think about that. What are factors of 30 that have a difference of 1? Because many times now in the future, you're going to be doing this mentally. So I know 5 times 6 is 30, and it has a difference of 1. Now notice the middle term is positive, so my larger factor will be positive, and this one will be negative. And if I FOIL it, that's my check. Now keep in mind, as you practice the FOIL, you're reinforcing your knowledge of the earlier part of the chapter. And there's our answer down there. Now, as we look at this, they're introducing a new vocabulary word, the word prime. Prime indicates that we cannot factor what is there, this trinomial. There are no factors of 7 that are going to give you a middle term of 1. So the factors of 7 are 1 and 7. So the difference are going to be 6. Now, if this were 6, that would be good, but it's not. Or no, actually, since this is negative, then both have to be positive. So again, there's no possibilities. So this is prime. Now, is there a way to solve this if this were an equation form? Yes, and you'll be doing that in Math 105. Okay, so here's sort of a summary of what we've been doing. Step 1, put it in standard form. Step 2, and I have them numbered a little differently, always factor out the greatest common factor. In some cases, you may even want to factor out a -1 to reverse the signs. And here, I guess they have these two switched around. I would always do 2 first. Have it in standard form. Then there are these other steps that we've described. If you want to write them in your notes or read them over, pause the tape. And then you're always going to check, this is critical, by foiling. Okay, now what we've done is we've switched from quadratic expressions to quadratic equations. We have it in standard form. It's now equal to 0. We are now going to try to solve these equations by factoring. So it's in standard form, no common factors, 2 sets of parentheses, equaling it to 0. So an x there. They gave us a nice easy one here. Next step, equate. Remember, we're using the principle of the 0 products. In order for this to be true, one of these or both of them have to be a 0. So we're going to see what makes this a 0. X plus 2 equals 0, or x plus 3 equals 0. Now here we're just transposing. X equals -2, x equals -3. Those are our 2 answers. By the way, if we put this in this equation, it makes it a 0. And if we put this in this equation, it makes it a 0. And if we were to graph this, which they're going to show us as well here, if we write it as a function, there's our graph. It's a parabola and our. Now to put it in standard form, we have to +2. So we end up with this. Now this is in standard form, and we're going to factor that. So our x is there, and we want a 4 and a 3. Again, I think we've done one like this already. They're both going to be negative. And when we solve it, we're going to say x minus 3 equals 0, or x minus 4 equals 0. And then we end up with x equals 3, or x equals 4. Now, if we put either of these roots solutions as x in the original equation, they will work. And again, you had to put this in standard form by foiling the factors, transposing the -2, factoring it, equal each factor to 0. These are your roots. And there's where you get the transposition. There's the factoring. And notice I had my -3 there, -4 there. This is fine. Not a problem at all. And those are my answers. And if we were to put it on our graphing calculator, you would see you'd get your answers there. Okay. Now, what they're going to ask you also in some of your work is to reverse what we've done. They're going to give you the answers. Then from the answers, they want you to write the equation. And it's not too hard. Let me show you how it works here. Write a polynomial whose functions, whose zeros were a -2, a 0, and a 3. Well, let me set this up for you. Okay, so we're going to work backwards. So this was our answer line. Now, when we have 3 answers like this, that means we factored out an x here somewhere, and there's an x all by itself. So they slipped that in there without giving us a practice example here in our notes. But we know that if we had x equals a -2, this appeared as a factor as x plus 2. And if we had x equals a +3, this appeared in our factors as x minus 3. So can you see from this line to this line? And this one here is a little tricky because we hadn't done it before. Okay, so now what I'm going to do is I'm going to FOIL this. And keeping in mind I have an x out there. So this is going to be x squared. My outers, my inners give me a -x. And this gives me a -6. So I'm just foiling these two. And now to get to my top line, I'm going to distribute that x. So this becomes x to the third minus x squared minus 6x equals 0. I remember at the Boy Scout camp, sometimes we would have upside down day, where for breakfast we'd have supper. Lunch was lunch, and then for supper we had breakfast. Well, I think most people like to have supper at supper, but here they want your mind to work this way. Here are the answers, and then it goes this way, then this way, and then finally that is your equation, working backwards. You know the zeros when x, or when the function is equal to 0, then you get these answers from this function. And all we have to do here is put like a function here. and then this is 0. Okay. So again, you're reversing everything, and that's what you get. And that'll wrap this up.